Think about the last time you slept somewhere new. A hotel room, a friend's couch, a vacation rental with blackout curtains, and a bed that should have been perfect. You were tired, the room was quiet. There was no reason, no good reason, why you couldn't sleep. And yet, you lay there for an hour, maybe two, drifting in and out of something that felt less like sleep, and more like a long, restless negotiation with consciousness. Every creak of the building pulled you back, every passing car, every unfamiliar sound from a ventilation system that your brain refused to file away as harmless. You woke up the next morning feeling like you'd been on guard duty all night, which, as it turns out, is exactly what you were doing. Because while you thought you were sleeping, half of your brain wasn't. In 2016, a neuroscientist named Masako Tamaki at Brown University published a paper in Current Biology that answered a question most people didn't know to ask. She wanted to know why humans sleep so poorly in new places. Not the vague, obvious answer about unfamiliar environments, but the actual neural mechanism. What is the brain physically doing differently on that first night? What she found is one of the stranger things I've come across in sleep research. On the first night in an unfamiliar place, the left hemisphere of the human brain does not fully sleep. It enters slow-wave sleep, the deep, restorative phase, but it stays measurably more active than the right hemisphere. Its default mode network, the web of regions associated with self-referential thought and environmental monitoring, remains lit up. And crucially, the left hemisphere responds faster to unusual external sounds. A door closing somewhere down the hall, an unfamiliar hum from a ventilation system, and triggers waking more readily than it would in a familiar environment. The right hemisphere sleeps normally. The left hemisphere keeps watch. By the second night, the asymmetry disappears. Both hemispheres sleep at the same depth, with the same responsiveness. The brain has decided, on whatever timeline it operates by, that the new place is safe. But on that first night, it hasn't decided yet. Now, before you conclude that this is simply anxiety, that people who sleep poorly in new places are just nervous travelers, light sleepers, people who think too much, consider what Tamaki's team actually tested. The participants weren't anxious. They weren't stressed. They were ordinary sleepers brought into a controlled lab environment, with no particular reason to feel threatened. The asymmetry appeared regardless of how relaxed they felt, regardless of how tired they were, regardless of whether they consciously registered any concern about the new environment at all. The brain was not responding to what they felt. It was responding to what it detected. And what it detected was simple. This is not the place we know. The threat assessment is not complete. The left hemisphere stays on. Now here is the part that changes how this feels entirely. You are not the only animal that does this. Dolphins sleep with one eye open, literally. When a bottlenose dolphin sleeps, one hemisphere shuts down completely while the other remains fully awake, monitoring the environment, watching for predators, maintaining enough alertness to surface for air. Then the hemispheres switch. This is called unihemispheric sleep, and it has been documented in dozens of species. Dolphins, whales, fur seals, many species of birds. A mallard duck sleeping at the edge of a group will keep the eye that faces outward open, its corresponding brain hemisphere alert, while the eye facing toward the flock stays closed. Move the duck to the center of the group, away from the exposed perimeter, and both eyes close. The brain adjusts its vigilance in real time, based on its assessment of risk. Humans were supposed to have lost this. We are not dolphins. We do not consciously keep one eye open. But Tamaki's research suggests we never fully lost it at all. What we have is a weakened vestigial version of unihemispheric sleep, one that surfaces only when the ancient threat detection system in our brain decides that the environment has not yet been cleared. It is quieter than a dolphin's, less complete. But it is the same mechanism, running on the same ancient logic, making the same calculation it has been making since the first human beings spent a night somewhere unfamiliar. And it makes the decision without asking you. For most of human history, this system was not a problem. Your ancestors spent their lives in the same small territory, sleeping in the same place or within the same familiar cluster of places, surrounded by the same sounds and smells, and the same people they had known since birth. The cave was known, the camp was known. The sounds of the night were cataloged and filed. The first night effect might have been triggered a handful of times in an entire lifetime. When the group moved to a new seasonal camp, when a young person left their family for the first time, when a flood or fire forced a change of shelter, the left hemisphere kept watch on those nights. It assessed the new environment, found nothing threatening, and by the second night it stood down. Then came the railways in the 1840s. The expansion of the British rail network created something that had never existed before in human history: the business traveler. Within 30 years, British railways were carrying 300 million passengers a year. Hotels became an industry overnight. Traveling salesmen, engineers, government officials, merchants, for the first time, sleeping in an unfamiliar place, stopped being a rare, extraordinary event in a person's life and became something ordinary people were simply expected to do, week after week, without complaint. By the 21st century, the average business traveler sleeps in an unfamiliar place more than 80 nights a year. 80 first nights, 80 nights with one hemisphere of the brain, refusing to fully rest, scanning for threats that aren't there, standing guard in a room that has already been assessed by every conscious system available and declared perfectly safe. The brain doesn't care what your conscious systems think. It has its own timeline, its own criteria. And until those criteria are met, until some threshold of familiarity is crossed, that no one has yet been able to precisely define, it will not stand down. The researchers who study this have noted something that should genuinely unsettle anyone who travels regularly for work. The accumulated sleep debt from repeated first-night effects does not fully resolve between trips. Each disrupted night carries forward cognitive costs, slower reaction times, reduced working memory, impaired emotional regulation, diminished creative thinking, that compound across weeks of frequent travel. A person who spends 80 nights a year in unfamiliar places is spending roughly a quarter of their year with a brain that is running at a fraction of its capacity on a timeline that evolution designed for a life spent largely in one place. Nobody told the modern economy that. Nobody consulted the left hemisphere when they designed the quarterly business travel schedule. And so millions of people lie awake in identical hotel rooms across identical cities, staring at ceilings they will never see again, feeling vaguely broken, wondering why they can't just relax, why they can't just sleep, why their body refuses to cooperate with something as simple as closing their eyes in a quiet room. The answer has been sitting in the left hemisphere the whole time. So the next time you lie awake in a hotel room, or a friend's spare bedroom, or your first night in a new apartment, or anywhere that isn't the place, your brain has already decided is home. Your brain isn't broken, it isn't anxious, it isn't overreacting, it isn't weak. Half of it is doing something it has been doing since before your species had a word for sleep. Something dolphins still do every night, and birds still do on every exposed perimeter, and every creature that has ever had to survive a night in an unknown place still does, automatically, without instruction, without fail. It's keeping watch, it just doesn't know yet that you're safe. And the saddest part, the part that stays with me, is that the world you live in will ask it to do this again next week. Another city, another unfamiliar ceiling, another night with half a brain standing guard, in a room that poses no threat whatsoever, running an ancient program that was written for a life, nothing like the one you are living. It will do it without complaint, long after the threat that made it necessary stopped existing.